Hi, welcome back to Bye Forever. So, hopefully, for you guys, hopefully this is going to be the last video in the Arduino Space Invaders series. I've got it to the point where I'm reasonably happy with it. I know there's a few little bugs, little things that could be ironed out. I prefer to call them features. So it's not a bug, it's a feature. But what we've got, essentially, we've got a bit of sound output when an alien gets hit. We've got in this version we've got 5 rows by 5 columns of aliens. I've actually managed to get the timing improved to the extent that they all line up vertically. We've got a little rudimentary scoring system, which is a bar that runs across the top the more that you've hit. The user player, obviously, as before, can move left, right. Barriers don't really do anything other than add a bit of a visual aspect to make it look a little bit more like the original Space Invaders. And when you fire, a little shot goes up the screen. So let's just have a quick go at this. So, oh yeah, and forgot to mention, every time the aliens move down by one line, it outputs a little click. So let's see if we can hit an alien. See a bit of a feature there where there's distortion. There you go, hit an alien. Yay. Hit one that time. Obviously I've got a camera in front of me, so I'm trying to do this slightly blind because I can't see some of the screen. There you go. So when you hit one, you get a bit more of a sound. Yeah, and actually another feature, sometimes it loses the TV sync when it's playing the sound, especially when the last column of aliens is near the end of the screen. I think that's just because you're attempting to draw off the end. Try and get a last one there. That last one's annoying me now. Because that, again, oh, I've got it. Brilliant. So again, that's another feature. That what you've got to do is, when you've effectively when you've shot an alien, deleted it, are actually still drawing an alien, but with pixel set to off in that timing gap, and that doesn't quite line up fully, so the aliens to the right of that actually look a little bit distorted. But you can think of it as if you know, they're actually scared that you're hitting them, so they're going a bit crazy. You could see it like that. With these sort of really basic video games like this, you've got to use a little bit of imagination. So they're almost at the bottom, and they're gonna actually hit soon, and then that's like the end of the game, and everything goes really weird at that point. All the barriers start moving across again. Really, it shouldn't actually do that. And you start to lose TV sync at the end. So yeah, that's a quick demo of it. Probably just show the hardware a little bit as well again. So let's just rearrange the camera. So I've gone handheld for this bit, but that's pretty much the sum total of the hardware. At this end is the TV output circuit, which really is just like a potentiometer and a resistor connected. One end of it is connected to the TV cable, so that's outputting a PAL TV composite signal. The other end's connected to pins 12 and 13, and then we've got so sound output's done by that little speaker there, and a transistor to amplify the really small signal that you get from, sorry, I should say the small current that you get from setting a pin on the Arduino, and also to protect the Arduino from blowing up. because the last thing we want is to like damage the board or the chip or one of the pins on the chip. And then we got the left and right fire button, sorry, the left and right player control buttons, and then the fire button there. So when you press that, that's when you get shot firing up the screen. Just reset it again. Yeah, so that's sort of the sum total hardware. I'll try and just bring up the code and maybe zoom in as well on, because I know some people, there might be sort of one person out there that wants to try and make this, and I did try to produce a little Tinkercad picture of all of this, so I'll try and show that next. So this is Tinkercad. It's absolutely free as far as I can tell. It's just an online sort of Arduino microcontroller prototyping CAD drawing package. So it's got like all the pictures and pins and things. Does simulation as well apparently. I've not used that, but so yeah, I'll just adjust the camera a little bit down. So yeah, this is showing the breadboard that I just showed before, and all the connections, the Arduino, little transistor, resistor, and speaker there. The composite TV output's actually represented just by this resistor here, because there wasn't anything in Tinkercad to show that kind of connector. And yeah, so you got the left, right fire buttons, and sorry, said it again. The left and right player controls, and then the fire button. And that's it. Yeah, hopefully that sort of describes the hardware enough. If you zoom in on the video, you might be able to wire that up yourself. If I'm sure there's probably literally no one else out there. I would love someone to prove me wrong and actually go and build this as well, and it's fairly fun to do. On top of that, then we've obviously got software. So software is generating a TV signal, a PAL TV signal, as I mentioned. It's obviously just black and white. We haven't got enough processing power on the Arduino to do full colour. You need something, well, it's going to have to be possibly like a Pico, Pi Pico, or an ESP32 that might have enough CPU power to do this, run at a fast enough clock rate. So this is just a wiki page showing the PAL TV signal. So yeah, you can have a look at that for the description. It describes it way better than I can describe it. All the timing's there. It's available on that and on the other images that you can find. So I've just opened up Eclipse and probably run through a bit of the code. I'm not going to do an in-depth line by line description of how this works. That would firstly take way too long for this video, which I'm attempting to keep to 10 minutes, which might end up being 15. And also, yeah, some of this code is a while since I've written. The code is on GitHub, and I'll put a link in the description. So anyone who's familiar with C, C++, and also bits and pieces around the Arduino. We're doing everything, it's worth mentioning, we're doing everything here using not the Arduino IDE, but just a straight C compiler to compile C code, which is why we've got int main there. We're including the avr/io.h, the header file for that, which is where a lot of these constants come from. This ddrb register macro, and all of these, which are just the pins. So so effectively after we've done all this setup, it drops into while one, so an infinite loop. We've got this part here. This is a timer interrupt which triggers at a rate of 64 microseconds, and that's to give the horizontal sync rate of the TV signal. So in each line of the TV screen has got to be drawn in 64 microseconds, or else the TV can't lock onto it. So you've got to trigger a horizontal sync pulse at that rate, and that's what this bit of code does, labelled in the comment handily hsync. Some of this code I've got from Ben Heck on his video. So he didn't actually give a link to his code, unfortunately. I really wish that it had done. It would have made this a lot easier, but some of this code, bits and pieces that I saw on his ATtiny 10 video console, and that video was actually the inspiration for me doing this. So, you know, if it wasn't for that video, I wouldn't have even bothered or known enough, or been able to find out enough to be able to do that. So you also have to trigger a v-sync pulse of vertical sync after the number of lines in the TV screen. Can't actually remember off the top of my head what that is. I think it was on that PAL. Just bring up the website again, the wiki page. 625 lines, but not all those lines are visible. So regardless of that, so yeah, all you need to know is you need to do a vertical sync at the refresh rate of the screen, which reset the line counter. That's one of the things we do, and trigger the fact, or set the flag for VSync to 0, saying we're not doing a VSync, and from now on we're just doing horizontal syncs until the end of that full screen is drawn. And at various points, at various lines, when the line counter has to set certain things, we're actually triggering different bits of code. A lot of this code, when you look at it, you might think, well, yeah, you could do that with the for loop, or you could do that bit of code with a, you know, like a bit of if then else logic. But actually, this is the only way I've been able to get it to work. Switch statements seem to be very fast, whereas an if then else all the way down here just ends up being, you know, too much overhead in terms of time spent in that logic. Also, when you create a loop, a for loop, there's a bit of time spent setting up the loop, and then obviously you've got to check if a loop's complete, or sorry, the compiler creates code to check if the loop's complete. But I'm, as much as possible, tempted to do this just with a switch and case statements. So I've been fighting the whole way through this project to maintain firstly TV synchronization, and also the alignment of everything on the screen, so the columns of aliens, and it's one of the most difficult bits of code I've written. And yeah, all of this looks really messy, but if you put some of these things into you know, arrays, and then sort of add a loop around this, that basically does not work. Also, if you use anything other than bitwise operations for the status of each alien, it just doesn't work. If you have logic to do the same thing, forget it, it's too slow. And yeah, so that sort of switch statement controls what happens. I think early on in the screen, just page up rather than using the mouse wheel. Yeah, earlier on in this, you've got the bits of code that read the buttons, check the input control buttons, check for one of the most important things if the game's won, and that basically means the alien bit pack status are all 0. And so, as I say, check the fire button being pressed. There's lots of debug arrows using to align the fire button press and that with the call of aliens. And then there's code. Oh, actually, as well, it's worth saying the code doesn't fully start, or the game doesn't start, should I say, until you press the fire button. And this is to control the left, right. Oh, sorry, this is to control the direction of the aliens. So they're moving to the right, you're adding to that, and if they're moving to the left, you're subtracting from the alien start position. There's also bits of code to move the aliens down screen when they get to either end. So that's what this does. That's a really quick run through. Oh, so I should say there's also there's a header file in there. Oh yeah, this function here, this inline function, I don't actually use that because this was just way too slow. And passing in, I had some, instead of that massive block of logic, where are we there? Instead of this checking if the aliens are hit sort of code there, it's looks really horrible. But attempted to change it to this with like and a for loop calling this function. It was just too slow, so and yeah, rather than using anything like so there is a function you can call in this AVR C development environment, which is underscore delay US. So that's a microsecond delay, and unfortunately it only takes a double as a parameter, so you can set it to whatever you want, but it's got to be a constant. And so I wanted something that's variable, because you essentially, to get the X position, or the horizontal position of the aliens and everything else on the screen, you've got to use a delay. So you're delaying the time, which delays where the pixel effectively is drawn on the screen. So I was using, instead of, and this is actually quicker than using a for loop as well. So this is a sort of a NOP, so that's no instruction, so no operation. So I've defined that, as you can see by the little macro expansion pop up, as assembler volatile NOP, so no op, and that is effectively 1 clock cycle. So there's a bit of overhead. This is inlined as well, so it uses more memory, but it's basically the quickest way I could get a little delay loop. Oh, I was messing around with attempting to write some text on the screen which basically says "You've won" or "You won." Couldn't get that to work yet, and yeah, that's to do with again drawing some character on the screen. So the rest of this in this ASM util .h file is all to do with yeah, these are sort of macros which set the pin 12 and 13 to the different values you need to generate the different levels in a TV screen or a TV signal. Actually, there I've got this macro is at 100 NOP for timing. I don't think I use that anywhere, but there's 5 NOP, 5 NOPs, 10 NOPs. So you could sort of, it makes the other code look a bit better. It expands the same thing, but and then there's the alien draw functions. So again, I'm using a switch statement and the line count. So for each line on the screen, there's a bit of logic in the main loop which says effectively if you're drawing an alien, it cycles around 0 to 7, and that then feeds or is passed into this function, which says you know, draws each pixel on the screen for that alien. Yeah, I'll draw the legs of the alien. So there's an alien draw 1 and an alien draw 2. So that's to give you the 2 frames of animation. And as I mentioned, I think earlier in the video, there's a draw blank, and all of this has been, I've tried to carefully construct all of these so they give the correct timing. And again, we're generating a TV signal, and it doesn't wait for you to, you know, like, oh, wait for you to draw the correct pixel. You've got to do it in the line horizontal sync rate. Yeah, so that's really, I think, as far as I'm going to go in this video. I think I've shown a bit of the code that we're using. Again, I'll put the code I'll put a link to the code in the description. I've shown a little bit of the hardware, did a bit of a demo of the game as well. And yeah, thanks for watching. If you got this far, well done to you. And stick around for more 8-bit videos in the future. I am trying to grow the channel slowly. I look at other people's channels, and you know, where they go like thousands of subscribers, hundreds of thousands of views, and I'm not sure what their secret is. Maybe I think they're probably just better videos, better at presenting. But I'm trying my best with this. Obviously, I'm not getting paid for this. There might be ads on the video, but I don't see any money from that. So if you like the video, please press the like button, and if you like the content, please subscribe. I think that helps the channel a bit. So yeah, thanks for watching, and bye for now. There's also bits of code, excuse me.